Welcome to class 9. Here we are going to continue upon from where we have left in the last class. In the last class we were looking at several point symmetry operations. We talked about rotations. We just spoke about certain rotations because certain other rotations, which is 1-fold, 2-fold, 3-fold, 4-fold and 6-fold. We said the other forms of rotations are not compatible with crystals, and by crystals I mean crystals with translational periodicity or translational symmetry. But I mean if you compromise on the translational part of symmetry, there are what are called quasi crystals in which these other rotational symmetries can exist, right. So, we looked at the rotation point symmetry operations. From rotations we have come to inversion operation, and from inversion we have also looked at what mirrors are, right. So, you can have these operations which are just mirror operations. Okay. So, today we will look at what are called we will start by looking at what are called rotoinversion operations. Now, until mirrors, right. So, the Schoenflies notation and the ITA go sort of parallelly with each other. Both of them have similar definitions of what a 2-fold axis is, what a 3-fold axis is, what a mirror is, what an inversion operation is, etc. But when it comes to rotoinversion operations, the Schoenflies notation does not have rotoinversion operations, it has what are called rotoreflection operations. They correspond at some level, but in order not to confuse you, I am not going to talk about Schoenflies notation when I am doing a rotoinversion operations, right. Now, rotoinversion operations, so I am just going to talk about this from the framework of ITA or ITA notations. Okay. So, now what is rotoinversion, right. So, about a point I rotate by a certain angle by n-fold rotation and then I invert, right, and I do the same thing again and again until I get back that point. Okay. So, that is what. So, I'll give you an example of what is rotoinversion. For example, okay, so let us start with the first rotoinversion operation, which is 1 bar, and 1 bar we have seen is nothing but inversion, right. So, which means so by definition of what rotoinversion is, if I have an asymmetric unit here with pointing up, right, and the chirality is right handed, then by 1 bar what I mean is I rotate it 1-fold, which is I rotate it by 360 degrees, which means it comes back to the same position, and then I invert it. It is equivalent to just inverting it, right. So, because 1 is an identity operation, right. So, then this is nothing but inversion, right. So, I have this goes to minus and then there is the chirality has changed. Okay. So, this is 1 bar is a rotoinversion operation in in its entirety, right. So, but we just studied it as a simple inversion operation. Okay. Now, we will again follow the same laundry list of rotation operations, but using the caveat that now what we are going to do is rotoinversion, right. So, what about 2 bar, right. So, we go to 2 bar. Now, what is 2 bar? 2 bar is a rotoinversion operation, which is so I am going to write it like this. So, I am going to color just a part of it and leave a part of it empty, right. So, this oval. Now, I have an asymmetric object which is pointing up, right. I rotate it 2-fold first, but I do not put the object there. I rotate it 2-fold and I invert it again. So, if I rotate it 2-fold, it is coming here, but the object is not there, right. So, the object is actually you should not be putting it there. By 2 bar I mean I do one rotation and then I do an inversion, right. So, when I do an inversion, what happens is this goes again back to that position, and so the chirality changes and it when I invert it, it is also going to negative side, right. So, the chirality has changed. So, I am going to represent it as slightly bigger object, there is plus minus, the chirality has changed. Okay. So, there is a comma and there is a dot or nothing, right. So, there is both right handed and left handed. So, above the plane I have so I have an object, right. So, which is whose chirality is right hand, and below the plane I have an object whose chirality is left hand. So, when I did a 2 bar operation, right, about 0 0 1, what I essentially did is an inversion operation about 0 0 1, right, sorry, a mirror operation about 0 0 1. So, I just put a horizontal mirror, right. So, that is equivalent to rotating it twofold, rotating an object twofold by 180 degrees and then inverting it, make x y z as minus x minus y minus z, change its chirality, and then that gives me a 2 bar operation. So, 2 bar operation is the same as a mirror operation. Okay. So, nothing much more to spend time on this, right. So, I can either use m or I can say 2 bar, this is one and the same. Okay. Now, let us go to the next operation, which is 3 bar operation, right. What is 3 bar now? 3 bar is, again I have a triangle. I will leave the center of the triangle as an open circle and I am going to just color the rest of the triangle, right. So, this is how you denote a 3 bar operation, right. So, it is a triangle. So, a threefold operation is the triangle is completely filled, I mean completely colored, right. So, completely shaded, whereas a 3 bar you leave some of it open to say that I am also inverting, I am not just rotating. So, this is the convention for representing a 3 bar operation. Okay. Alright. So, now I have a 3 bar operation. The way I am going to understand a 3 bar operation is as follows. I have an object, an asymmetric object which is pointing up, alright. I rotate this asymmetric object by 120 degrees, right. So, not 60 degrees, but 120 degrees. So, I get the same object which is pointing up, but that object is not there, right. So, I do not place it there, rather where I place it is I invert it and I am going to place it here, right. So, that is an equivalent of rotating it by 60 degrees, but in the clockwise direction, right. So, not 120 degrees in this fashion, but 60 degrees in the clockwise direction, but not just that, I am inverting it. So, I have an object which is going down, right. So, with a and the chirality also changes, right. So, the object which is up is rotated by 120 degrees and then inverted, right. So, that it goes down the plane, right. So, bottom below the plane and the chirality also flips. If I have a right hand here, I should have a left hand here. Okay. Okay, then I should do this until I get back the same object, right. So, if there is 3 bar, which means this object exists, this object exists. So, there should be a 3 bar symmetry about this object also, right. So, this object also should follow the same laws. Okay. So, what am I going to do? I am going to rotate this object by 120 degrees, which is supposed to bring it somewhere here, right. So, I am going to point it, but I am just not going to draw anything there, but then I invert it so that I so this is 60, this is 60, okay. So, I invert it so that I bring it here, but now I am again going to change the chirality and bring it up the plane, right. So, like that you can fill the entire space. Here I will have minus, here I will have plus, here I will have again minus, but with negative chirality. So, what have you got here? So, what you have got is so I have an object with this. Okay, so let me use a brighter color so that it is more visible. So, I have an object in the plane of this in the plane of this black triangle, which is above my plane, right. So, where I am doing the 3 bar operation, and I have another triangle of objects, right. So, this thing which is below the plane, right. So, if I have 3 bar symmetry, I should see these sort of star shapes, right. So, or it is not really a star. So, I have a triangle above my point and I have a triangle below my point, but these triangles are sort of rotated with respect to each other, right. So, that is a 3 bar operation. Okay. Now, if I look at what what sort of an object, right. So, if I just make an object like this, right. So, I have so I have some sort of an entity here, and so I make, so I am drawing the cross section of this, right. So, I have a triangle which is pointing in this fashion here, and I have a triangle which is pointing in this fashion here, right. And then I sort of ask you what is this object that has formed, right. So, about this as the center, right. So, there is nothing here, but about this as the center, what is the object that has formed. Okay. So, the answer you can think about it is this object is actually an octahedron, and the center of my octahedron is my point where about which I have a 3 bar axis of symmetry. Okay. I mean, so this is an octahedron, and the center of the octahedron is something where I have a 3 bar axis of symmetry, right. You can see that there are 6 corners, right. So, there is one triangle on the bottom, one triangle on the top, you can combine them, and that object is by definition it is an octahedron. Okay. So, octahedron has 6 corners, and so I have 6 corners here, and the center is the point symmetry about the center is a 3 bar axis, right. So, about an octahedron where all the corners are identical, I have a 3 bar axis of symmetry for this unit which is an octahedron. Okay. So, I will give you some examples later on, but okay. So, that is 3 bar. Now, equivalently you may argue that okay, so 3 bar operation also seems to have a threefold axis of symmetry, right. So, because I have one triangle where I have similar objects, right. So, plus plus plus, and I have another triangle which is bottom which has minus 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 with reversed chirality, right. Now, this has a threefold, I mean, so the triangle that I am representing the central axis is both a threefold axis of symmetry, but it is something more than threefold axis of symmetry, it is also a 3 bar axis of symmetry. So, one may argue that I can just do a threefold axis of symmetry operation and then invert this. So, if I invert this triangle, right, I will get this triangle. Right. So, instead of doing 3-fold axis invert, 3-fold axis invert, 3-fold axis invert, I can generate all points through a 3-fold axis of symmetry, 3-fold operation, and generate the remaining points just from inversion operations. It looks like the order of operations is not important. I can first do 3-fold. I told you, right. So, initially when I said if you are actually going to rotate this, you rotate it by 120 degrees, but do not put a point there. That is what I said. I clearly said do not put a point there, you put a point which is so the inverse of this, right. So, that is where you put the first point, right. So, first object. However, what I am now arguing is but this is equivalent, this looks like it is equivalent to, I can as well have, I could as well have put a point here, I could as well have put another point here, right. And then I could have gotten to a 3-fold operation, that is okay, and then later on I will invert each of these things which are falling on this black triangle, I will invert it and get the pink triangle, right. So, that so whatever you said do not put a point there, that seems to be exaggerated, and so there seems to be no merit in that. Okay. In case of 3 bar it may seem like that, right. So, 3 bar seems like I can first do all my 3-fold operations and then bring back all the points by just doing an inversion. Okay. So, in fact later on I am going to talk about 3 bar as a point group which has in it, right. So, this group the subset of this group is nothing but the subgroup of this group is a 3-fold axis of symmetry as well as an inversion, right. So, you can do 3-fold axis of symmetry as well as inversion and get to a 3 bar operation, right. So, that is perfectly okay for 3 bar. Okay. But next I am going to talk about what is called 4 bar where such a thing does not work. Okay. So, what is 4 bar? So, by our definition, if you do not forget our definition. So, I have something like this a stereogram, right. So, now 4 bar I am going to represent it again as a diamond with part of it colored and part of it uncolored. Now, in this diamond I am going to start with an object which is pointing up, right. Now, this object I take it 90 degree rotation, I do not put an object there, right. So, I do not put my asymmetric object there, this 0 and plus is an asymmetric object, but I do not put an asymmetric object there, rather I invert it, right. So, I invert it to this position and put it here, right. But if I am inverting it, it goes down, right, as well as the chirality changes. Okay. Then I do exactly the same operation with this asymmetric object. So, it is supposed to come here when I do a 90-degree rotation, but I do not put an object there, rather where I put an object is inverse of that, which is here, and the chirality changes, which means it comes back to the original chirality and it comes up. Okay. And I exactly do the same thing here and I get another object which is here, right. Okay. So, this is equivalent to I have one line, right. So, if I am combining all these asymmetric objects, I have one line which is coming above the plane, which is here, and I have another line which is going, this is the blue line, and I have the black line which is coming below the plane, right. So, it is something like this, this is my 4 bar symmetry, right. So, I have an object here, here, here and here, right. So, however, my center of so these two lines are perpendicular to each other, and the center of these two lines defines what my point about which 4 bar symmetry is being accrued, right. So, the point about which 4 bar symmetry is being operated. Okay. So, this is the point, but about this point I have one line on the top, one line on the bottom, right. So, this is 4 bar. So, even if you do not remember anything, just remember, look at me and then remember that this is 4 bar. Okay. All right. So, now if I have a 4 bar operation, what is the corresponding? So, I have I just told you that 4 bar is similar to having one line here, another line behind the screen, one line above the screen, another line below the screen, and so there is an object that comes, and then the center of it is my object about which there is a point group 4 bar symmetry. Now, if I just join all these vertices, what is the object I get? I in fact get okay. So, this is one triangle, this is another triangle, and there are 2 more triangles on the back, right. So, what I get essentially is a tetrahedron, right. So, if I have just a tetrahedron with all the corners occupied by equally symmetric entities, then about the center of the tetrahedron I have a 4 bar symmetry, right. So, the object that I am making here is a tetrahedron, right. So, that is why this 4 bar so this is a tetrahedron. Okay. All right. So, now look at what we did with 4 bar. So, I have an object here, I have the same object here, whereas the object goes down here and the chirality changes, the object goes down here and the chirality changes. Now, imagine instead of doing 4 followed by inversion immediately and 4 followed by inversion immediately, that is 4 bar, this is 4 bar. If I do first a 4-fold operation, first I do a 4-fold operation. Right. So, in this 4-fold operation, I have an asymmetric object here, I am going to put it here, I am going to put it here, I am going to put it here, right. So, then to the ensuing object, objects rather, I perform inversion operations. So, what do I get then? I have something here, this has here, here and here, right. So, to this if I perform inversion, I will have this goes so I will have objects which are both above and below, and objects whose chirality is both right handed and left handed on the same locations, right. So, this is equivalent to putting a mirror, right. So, this is equivalent to having a 4-fold axis and a perpendicular mirror to the 4-fold axis. right. We will see that what this is called is this goes to what is called a point group, which is 4 by m. It is not really by m meaning by a mirror, a fourfold axis cut by a perpendicular mirror, but this is not the same as a 4 bar point symmetry operation, right. So, this is a point group essentially, which is different from a 4 bar point symmetry operation, right. So, so that sort of emphasizes the fact that rotoinversions are independent operations, independent point symmetry operations, right. In general, rotoinversions cannot be considered as a combination rotations followed by inversions. Rotation, point symmetry operation, rotation point symmetry operation, which means I rotate fourfold, right. So, I put objects at 90 degrees with respect to each other and I invert all these objects, right. So, I am doing it in that order, rotations, rotation point symmetry operation, followed by inversion. Okay. Right. So, when we do group theory, then we are going to say that 4 bar as a point group is not, does not contain 4 bar, or in other words, so 4 bar as a point group, I am going to talk about it when I do point groups, right. So, 4 bar also is a point group, does not contain itself in it a fourfold point group, fourfold operation or inversion for that matter, right. So, yeah, 4 bar does not also have an inversion, right. So, you can see if I just have a 4 bar operation, this is not inverted. So, there is no, so this is my 4 bar and I do not see there is no point of inversion, right. So, 4 bar is not a centrosymmetric point group, whereas 3 bar is. If you look at 3 bar operation, there is a point of symmetry, there is point of symmetry, right. So, 3 bar as a point group, again I am telling you what I am going to tell you in next two after 2 classes. I am going to introduce you what point groups are, which are related to, I mean, so simple point symmetry operations can also be considered as groups, but so point group means there are several point symmetry operations, but if 3 bar, you are considering 3 bar as a point group, there is a point, there is this, there is the operation of centrosymmetry, right. So, which is embedded in 3 bar, but that is not embedded in 4 bar, right. So, in 4 bar I do not have a point of symmetry, sorry, a point of inversion, not symmetry. Did I write symmetry there? A point of inversion, sorry. Okay. Whereas in 4 bar there is no point of inversion, or it is non-centrosymmetric. Again, here I am going, I was looking at all rotoinversions or simple point operations, point symmetry operations. Okay. So, I still did not define what a group is, so do not get confused, but I am just indicating you what is supposed to come next, which is so there is this point about which there is 4 bar axis of symmetry does not have an inversion. So, 4 bar is somehow not a combination of an inversion operation and a fourfold axis and a fourfold rotation, right. So, this does not have fourfold rotation, this does not have inversion, right. So, unlike in 3 bar, the point about which there is 3 bar axis of symmetry has a threefold axis of symmetry, as well as inversion, that point is also an inversion center, whereas here this point is not an inversion center, it is not it does not host a 4-fold axis of symmetry, right. So, it is a unique point in itself, and 4 bar is a different point symmetry operation altogether. Okay. So, that is what I mean. Okay. I will just not write this right now, I will write it when I do groups. Okay, good. Now, what about the other? So, again we do not talk about 5 bar. If there is no rotation, there is no rotoinversion, because I do not have to rotate by 2 pi by 5 and invert it and get a something which is compatible with the space group, with the translational symmetry, whereas what I am going to talk about is 6 bar, right. So, now what is 6 bar? This is again rotoinversion. Again I color a part of it, I leave a part of it uncolored, so that I know that there is a 6 bar operation here. Sorry for multiple colors, but I am very bad at drawing. So, okay. So, if I have an asymmetric object like this, I am going to rotate it by 60 degrees and I am going to invert it. So, I bring it here with inverted chirality. I am going to rotate now this by 60 degrees and I am going to invert it. So, I put a point here again with inverted it should be at 60 degrees. I am going to rotate this by 60 and okay. So, that is correct. So, that will be again positive. Then I am going to rotate this by 60 degrees and invert it back. So, now I have something in the same position which I started with. I have a mirror sort of, right. So, I have a comma and it goes negative, right. And you can see that I can exactly do the same thing everywhere else. So, I am going to repeat this mirror. Okay, so again this and a positive, right. So, I have on the top of the plane I have an asymmetric object, and on the bottom I have its mirror image, right. The chirality has changed. If I have a right hand here, I will have a left hand, if I have a left hand here, I will have a right hand here, and same thing, and this is rotated at every 120 degrees, right. So, 6 bar is this unique operation. However, I can also consider 6 bar as a combination of a 3-fold rotation, right, and a mirror perpendicular to 3-fold axis, right. Yeah. So, I mean but in this course we are going to consider 6 bar as a unique point symmetry operation. We are not going to consider it as 3 by m, right. So, this can also be represented as 3 by m, but we are not going to consider this at all as a point group, right. So, when we do group theory, 3 by m will just be 6 bar. So, I am not going to consider it separately. Okay. Okay. All right. So, 6 bar again is different from 3 bar. So, what is 3 bar? 3 bar, I had a triangle, it is an octahedron, right. So, I had a triangle which is pointing up and which is pointing in this fashion above the plane, and I have another triangle in red which is pointing below the plane in this fashion, right. So, what I have is essentially an octahedron, right. So, if I join the corners of this, I get an octahedron, whereas 6 bar is not giving me an octahedron. I have a triangle here and I have a triangle of the same orientation here. So, what I get is just a prism, right. In 3 bar what I am getting, the object that I am getting is an octahedron, right. This is assuming that all corners are populated with the same entities, right, and I am just looking at just this one polyhedron, right. So, it is not in conjunction with a lot of other things, it is just this one polyhedron isolated in space, right. So, then I have 6 bar symmetry in this prism, whereas I have a 3 bar symmetry in this octahedron. Okay. So, this is trigonal prism or yeah. Now, yeah. Okay. So, in the next class we will start by looking at some of these octahedra, prisms etc., in real crystals, right. So, where do they exist and tetrahedra for example in real crystals, where do they exist and so how do we understand them and what is so does this reflect in the global symmetry that the crystal has, right. So, you can have units such as these octahedra in a crystal, but so if it is like I have two dogs, just looking at them isolated it seems like there is a mirror plane, but I put them in an environment right. So, of a door behind and other things, then I can remove this mirror plane, right. So, similarly if I have objects such as this, by themselves they should have 3 bar or 6 bar symmetries, but the environment also should sustain the 3 bar or 6 bar symmetry. Okay. So, the object has a greater symmetry than when it is put in an environment, greater or equal symmetry than when it is put in an environment. So, that we will actually study in the next class. Okay. All right. So, with that so I will meet you again in the next class. Thank you.